Alright, in this set of notes we're going to be taking a look at angles. Our essential question is, how can a pair of angles be related? How can they be connected? So, we have several different ways. I'm not going to go into all the definitions technically, because that is part of your definition stuff, your vocabulary, but I want to just give some examples and make a couple of comments about each. So, first, we have adjacent angles. And by the way, the word adjacent means next to. You'll see that a lot. A lot of things are adjacent. That's adjacent next to. So, we would say that, for example, if I draw a diagram here, I've got two angles. Let's put some points here. Call this A, B, C, D. Put some measures in here. Okay. We would say that angle A, B, D and angle D, B, C are adjacent. When two angles are adjacent, we would also say this is the this is called the angle. Hold on a second. Okay, so I had a total brain fart there. Angle addition postulate tells us that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Or basically, the two small angles add up to the big angle. Alright, next we have complementary angles. So two small angles add up to a big angle. Two complementary angles add up to 90 degrees. Okay. So if I have, I'll call them A and B here, we would say that angle A and angle B are complementary. We could also say that the measure of angle A plus the measure of angle B equals 90 degrees. And this setup would be commonly used to solve equations. You might have some sort of expression for A and some expression for B, and you just replace those are the expressions and set up the equation. Expression plus expression equals 90, and solve. Next. Okay, let's see here. Next we have supplementary angles. Okay. So if I want to draw these a little bit differently. Here's why. I have, say, angle M and angle N. Okay. And I would say angle M and angle N are supplementary if measure of angle M plus measure of angle N equals 180 degrees. But angle M and angle N don't have to touch. And technically, complementary angles don't have to touch either. But I'd like to make this distinction here with supplementary versus the next one, which is linear pair. An example of a linear pair would be, say, angle 1 and angle 2. I would say that angle 1 and angle 2 are a linear pair because they are adjacent and supplementary. Another thing is they form a straight line. Okay. So they're supplementary and adjacent, which means that they form a straight line. So slightly different from just ordinary supplementary. Ordinary supplementary means they just add up to 180. Linear pair, they're going to add up to 180 because a straight line is at 180 degrees. Let's make a note of that. They are supplementary. So linear pair is a special kind of supplementary angles where they're also adjacent. Okay, last we're going to look at vertical angles. For example, here, if we have like 1, 2, 3, 4. Let's see, here's where it's convenient to number the angles instead of writing like A, B, C, C, B, D, and so on. So anyways, we would say that angles 2 and angle 4 are vertical. Okay. We would say that angle 1 and angle 3 are vertical. But also notice in this situation that angle 1 and angle 4 are a linear pair. Also, angle 1 and angle 2. Angle 2 and angle 3 angle 3, and angle 4. Okay. And the key with vertical angles is vertical angles are congruent, which means we would say, for example, angle 2, and there's the symbol for congruent, angle 4. We could also say what that means is that they have the same measure. So measure of angle 2 equals measure of angle 4. And we can use all of these properties to solve some problems, which is what I'll do in the next video.